Some common rules of probability that come up in basic statistics are the complement rule, which was covered in the previous section, a rule sometimes called the addition rule for the probability of mutually exclusive events, a multiplication rule for the probability of independent events, and various rules involving conditional probability. Conditional probability is the probability of one event happening given that some other event has also happened. The conditional event consisting of an event B happening on the condition that A has also happened is denoted with a vertical bar between the B and the A. The addition rule applies to events that cannot happen at the same time. Events that cannot happen at the same time are called mutually exclusive events. When choosing random numbers, for example, choosing one number implies not choosing some other number, so choosing 5 and choosing 6 are mutually exclusive events. The addition rule says the probability of choosing 5 or 6 is the probability of choosing 5 plus the probability of choosing 6. So, for example, if the probability of choosing 5 is 10% and the probability of choosing 6 is 10%, then the probability of choosing 5 or 6 is 20%. More generally, if A and B are mutually exclusive events, the addition rule says that the probability of A or B is P of A plus P of B. In equations, A or B is sometimes written using a character that looks like the letter U, which stands for union. In a Venn diagram, mutually exclusive events correspond to regions that do not overlap. If the events are not mutually exclusive, then the diagram looks more like this. This could happen, for example, if A is the event of choosing an even number and B is the event of choosing a number between 0 and 10, or in any similar situation where events A and B can happen at the same time. In that case, adding the probability of A to the probability of B would double count the probability of A and B happening at the same time. So to correct for that double counting, the modified addition rule for events that are not mutually exclusive is that the probability of A or B is the sum of the separate probabilities minus the probability of A and B. The multiplication rule applies to independent events, which are events where one event happening has no effect on whether or not the other event happens. In a binomial experiment, for example, it is assumed that the trials are independent, so success or failure on one trial has no effect on the probability of success on any other trial. The multiplication rule says that the probability of two independent events both happening is the product of the separate probabilities. So in a binomial experiment, if the probability of success on each trial is p, then the probability of success on 2 trials is p times p, the probability of success on 3 trials is p times p times p, and so on. In general, if A and B are independent events, the probability of A and B both happening is the probability of A times the probability of B. In equations, A and B is sometimes written using a character that looks like an upside-down letter U, which is the traditional notation for intersection. In a Venn diagram, independent events correspond to independent regions that may or may not overlap. If the regions do overlap, then the probability of both events happening corresponds to the region of overlap. Another useful concept in probability is the notion of conditional probability. For example, the probability of a seed germinating, depending on whether or not there has been any rain, is a conditional probability, where the conditional probabilities include the probability of a seed germinating on the condition that there has not been any rain, and the probability of a seed germinating on the condition that there has been rain. Here's a diagram to illustrate these probabilities. In this diagram, R represents rain and G represents the event of a seed germinating. Considering only the part of that diagram corresponding to the probability of rain, the fraction of that probability in which a seed germinates is the conditional probability of the seed germinating given that there has been rain, which is the probability of both events divided by the probability of rain. This definition of conditional probability can also be thought of as a modified multiplication rule for events that are not independent. By the earlier multiplication rule, if G and R were independent events, then the probability of G and R is the product of the probabilities. But if G and R are not independent events, then the probability of G and R is the conditional probability of G given R multiplied by the probability of R.